So this next problem, we're dealing with terminal velocity. We have a skydiver. Yay, I'm a skydiver. Yay. Yay. There's my skydiver. I guess I should give him hair and stuff. And he's falling to his doom. Okay? He has a weight of approximately 600 newtons. Let me rewrite that so it's a little more legible. 600 newtons. And he's achieved something that's known as terminal velocity, which means that he's moving at a constant rate. His velocity is constant. Okay? So that's a key thing you need to know, is the idea of what terminal velocity means. That means that the object is no longer accelerating. It's gotten up to a speed that it won't accelerate any further. And how that happens is that as the skydiver is falling to their doom, they're pushing air out of the way. And the faster they go, the more air they have to push. Well, that push back from the air, Newton's third law, slows down the acceleration of the object. And eventually it gets to a point where the upward force of the air is going to equal the downward force of the skydiver. Okay? And we call this force by the air, or more specifically by any fluid, and air is a fluid, drag. Okay? So what we want to do in this problem is determine what my drag is equal to. Okay? Now, once again, I'm going to reiterate. We're talking about terminal velocity, which means the velocity of the guy that's falling to his doom has reached a constant value. He's no longer accelerating. And when that happens, we achieve a system of balanced forces, that all the forces cancel each other out. So, looking at my skydiver as a free body diagram, I'm just going to put it over here because it's rather simple. We have the weight of the skydiver, the force of gravity, which always points to the center of the earth, and the drag up. Now, there may be other forces, there may be crosswinds or anything like that, but right now all we're concerned about is the value of the drag. Okay? This is actually pretty simple, because once I've drawn the picture, once I've understood what terminal velocity means, that the object's moving at a constant velocity, then this is trivial. I go to Newton's second law really quick, say the sum of the forces is equal to mass times acceleration. By definition, it's in terminal velocity. The acceleration equals 0, and so the sum of the forces equal 0. The system's in balance, which means that all my downward pointing vectors have to equal all my upward pointing vectors. So my downward pointing vectors is weight, my upward is drag. So drag being positive, put it first, minus the weight equals 0. Or we can say that drag is equal to the skydiver's weight, which means that the drag force is equal to 600 newtons. Okay? Things you need to know about this problem, and I'm going to reiterate, is the idea of terminal velocity. You need to know what that means.